This is all very exciting. NASA is launching its latest mission to Mars in just a couple of minutes from now. This is the Perseverance rover. Here's a live look at it this hour. It is scheduled to launch at any moment from Cape Canaveral in Florida, loaded with scientific equipment, cameras, and computers. This is, everybody, the most advanced vehicle NASA has ever sent to the Red Planet. Joining me now is York University's Paul Delaney. Hey, Paul, good to see you. Always a pleasure. Let's do a tie check-in to start. What are you wearing today?
Oh, well, it's the solar system. It was a very appropriate selection for today.
All right. And what is the new rover capable of, Paul, and what are engineers hoping to find here?
Well, this is the souped-up version of Curiosity that flew nearly 8 years ago, and we're still following the water. We're looking for signs of life. We're taking with us this time some ground-penetrating radar. We're going to be sniffing the atmosphere. We're even going to be converting carbon dioxide into oxygen in preparation for yours and I's trip to Mars a couple of decades from now. So there's a lot of stuff that is going up, and of course, amazing camera imagery will also be sent back from the get-go.
All right, looks like your audio was corrected itself there, which is great, Paul. Something else that makes this rover so special, the tiny helicopter. We've been talking about it all morning that's going to be attached to it. It's called Ingenuity. What is the purpose of that, and who's going to be flying it?
Not me, unfortunately. It'd be great if I was. Obviously, if you can get airborne, you have the opportunity to survey your surroundings. You can sort of scout ahead for where the rover is going. You can look on top of areas, little hills and so on, that the rover mightn't be able to get to. So this adds a whole new dimension to what we'll be able to do on the surface of Mars and above the surface of Mars. A very exciting engineering demonstration.
Very, very cool. Okay, so this trip to Mars is going to take around 6 months, and it ends with something engineers call 7 minutes of terror. Why do they call it that?
We hit Mars orbit traveling at about 21,000 kilometers an hour. We then have to get to the surface safely and therefore 0 kilometers an hour. So going from 21,000 kilometers an hour to 0 safely takes 7 minutes, and it's all done on autopilot. No commands from Earth. Everything is done by the onboard computers. So you can imagine you've got your entire career riding on this 7 minutes of slowdown, and you can't do anything except watch powerlessly.
Now, we are having a little bit of an audio issue with you. So for those that weren't able to make that out, you were talking about how the rover is traveling at 21,000 kilometers per hour. It has to go from that to 0 or 1 to 2 kilometers an hour before it safely lands. That is why it is called 7 minutes of terror, that's for sure. I'm going to bring Amory and Kelsey in on this conversation as well as we await the launch of the rover, which is expected to happen, I believe, in about 30 seconds' time. This is super exciting. Here again is a live look at Cape Canaveral. So, Paul, walk us through what's happening right now.
The launch team is being polled to make sure that every system is ready to roll, that the upper atmospheric winds are fine, counting down the last few seconds in preparation for unleashing all of the power associated with the Atlas, and it's going to take us into orbit and beyond. So
right.
Stand by.
Yeah, we're going to stand by and listen in for a moment. Thank you.
Release. And Atlas TU has gone to closed-loop control.
This is so cool. I can't imagine how deafening that
Coming
sound
up on
probably
30
is
seconds into flight,
at this
the
point.
RD-180 is throttling down as expected. Engine response looks good.
Absolutely. If you were at the Cape or anywhere near the Cape, you would really feel the launch as well as hear the launch. It is quite amazing by all accounts.
You know, I get really excited watching this. I know we all do here in the studio. But, Paul, when you're watching this, what do you see?
Vehicle is now passing through max Q.
I see the future. I see the capability of these types of vehicles taking you and I and anyone else who wants to into low Earth orbit, to the moon and beyond. So to me, this is a glimpse of the future. There's lots of science writing on it, but the ability to be able to do this regularly and do it safely, that really, really is exciting for me.
At this time in flight, the SRB chamber pressures remain nominal. The RD-180
I think also really cool watching this is just the idea of, like, this craft is never coming back to Earth. It is going to Mars. It is staying there.
We hope we get samples back to Earth that we can study later on, but we're saying goodbye to this forever and watching its journey as it travels to the red planet.
We certainly are saying goodbye, but remember that vehicles like this, the spacecraft itself, likely is going to continue giving us data for 10 years or more. Think of the Voyager probes that were launched 45 years ago. They are still talking to us. So while it won't physically be back, it will be giving us insight into its environment, hopefully for the next decade or more.
You know, it's amazing, Paul. It's always great to have you with us on the show here at Your Morning. A very, very exciting day. We appreciate your time. We may be saying goodbye to that, but hello to future exploration. Thanks so much. We'll be right back.
You're welcome.
Thanks for watching. If you like this, be sure to subscribe here.
And you can check out more Your Morning videos right here.